So we're going to talk about graphing linear functions, which again we've already talked about. So we're going to go back over slope-intercept form. We're going to go back over standard form. We're going to be talking about how to graph what's called a quick graph, which is using x-intercepts and y-intercepts in order to find the two values you need to make a line. Okay, we're going to be talking about horizontal lines and vertical lines, and that's it. So again, it's all stuff we've already talked about. It's just kind of making sure that we're good with the specifics, okay? All right. So anybody know what the term parent function means? What do you think it means? Original function, okay? For us, yeah, they're like our basic functions, right? So like your parents, are you exactly like your parents? No, but you're like them, right? So we're going to start off, a parent function is like our basic graph of an equation type is what I'm going to say. So that means that we're going to have like a parent function for linear equations. We're going to have a parent function for quadratic functions. We're going to have a parent function for cubics, quartics, trigonometric, logarithmic, exponential. Okay, all the different types of stuff we're going to be talking about, we're going to have a parent function for. And why that's important is because if you know what the parent looks like, you should be able to figure out what your graph should look kind of like, right? So if I give you a linear equation, what kind of line should it be? Should it be straight or is it going to have curves and stuff? It's going to be a straight line because it's going to be based off of this, right? Now with that said, I can take this graph and I can slide it up, I can slide it down, I can move it left, I can move it right, okay? I can rotate it like that, right? I can rotate it like that by changing the slope. Everybody good with that idea? Yes, no, maybe? So that's what we're going to be talking about here is how do we manipulate this graph in order to make the graph that we want, okay? So everything we're going to be dealing with today is going to look like this in some degree. All right, so that's all I wanted to cover. All right, so graph the following function. So there's a couple of different ways of graphing, right? We're going to go over the two, see if you remember. I told you, if I tell you to graph something and you don't remember how to graph, what do? Make a what? Make a table. What values do we use? If I ever give you something and you're like, I don't know how to graph it, that's where you start. Yes? Okay, so everybody good? All right, so plug in the x value. So plug in a -2 for x. What do you get? Negative what? -4. 2 times -1 is -2. Plug in a 0. Plug in a 2. What do you get? Okay, so how is this like the parent function? So let's graph it and see where we're at. What colors can actually show up here? The blue looks okay. All right, so we're going to be at 1, 2, 1, 2, 1, 2, 3, 4. We're still at 0, 0, right? At 1, I'm at 2. At -1, I'm at -2. 2, I'm at 4. -2, I'm at -4. So grab my ruler. And that's close enough to say it's good. All right, so does that look any different than this? It doesn't really look super different. So compare that with that. They're very similar, right, which we expect because that's a parent function for this. Are they actually different at all? Let's find out. So are they exactly the same? No, they're a little bit different, right? What's the slope of this line? If I said it's the parent function, that means it's just y equals x, right? Nothing special. What's the slope of this line? 1. And what's the y-intercept? 0, right? Because there's nothing added out here. So compare it to this. What's the slope of this line? 2. And what's the y-intercept? 0. So they're still passing through 0, 0, right? Here the slope is bigger, which means it's going to be what? More steep or less steep? It's going to be more steep, right? It's growing faster, which you can see in the graph right here that the dark blue line is growing a little bit faster than the light blue line. Everybody okay with how slope kind of impacts, right? Okay. Exactly. Which one's going to be closer to 90, right? The closer to 90 you are, the bigger your slope is. So it's still based off the parent, and this one looks almost identical to the parent. It's just a little bit bigger, right? So, you know, your dad's 5'9", and you're 5'10". You're just a little bit bigger. Okay, other than that, everybody good? Yes, no? So, everybody good with how slope impacts? So, again, our pictures are still based off of that parent function. So, when you're done, okay, or look like whatever the parent is. So, that's why it's important to be able to identify a parent function, so that way you know what your basic picture should look like. Okay, for the ACT, for example, they give you an equation and they give you 4 graphs, and you have to pick the right one. Well, if you look at it and you can see that the biggest power is 1, which tells you it's linear, look and see which ones are straight lines. If any of them curve, you can toss it out. Everybody okay with that? Yes, no? So again, remember, the ACT does not test your ability to do math. It tests your ability to pick the right answer if I give you 4 options. Okay. So again, if I graph this, what are my 5 values? Okay, so plug them in. What's -2 plus 3? -1 plus 3. 0 plus 3. 1 plus 3. 2 plus 3. Okay. So at -2, I'm at 1, right? So I just go through and I just plot my points. At -1, I'm at, -2, I was at 1. -1, I'm at 2. 0, I'm at 3. 1, I'm at 4. 2, I'm at 5. I did better this time, but I'm still not that good. All right, so there's my line, right? So again, how does this relate to the parent function? So what's the difference between this graph and my parent function? So let me bring up my parent, line up my axes. What's the real difference between this line and this line? Well, they're both straight, right? Well, let's check. It looks like it, but that's just because I'm off by a little bit. Okay, so what's the slope here? Slope. 1. Okay, what's the slope of my parent function? So the equation for my parent is y equals x. Okay, so slope is 1. So they should be parallel, are they? No, that's because I made them without a grid, right? So you know how you guys ask me, do I have to use graph paper? No. But if I don't use graph paper, does it guarantee I'm accurate? No. So if you use graph paper, you will be more accurate. Everybody okay? Yes. For a linear equation, it's always going to be y equals x. But we can manipulate it by sliding it up, sliding it down, left, right, or stretching it or shrinking it. So there's a lot of manipulation that can go on, but everything should be based off the y equals x. So what's the slope here, or sorry, what's the y-intercept here? And here? Okay, so what's the big difference between these two lines? So what I really did is I took my parent function and I just slid it up 3 units. Okay? And if we were dealing with a perfect world here, this should be more like that. Okay. Everybody good with that idea? Yes, no, maybe? So if you compare slopes and compare y-intercepts, it'll tell you what's wrong, right? Or what's different. So a change in the y-intercept just takes your parent function and slides it up or slides it down. A change in slope can either stretch it up the y or flatten it out across the x if it's bigger or smaller. And if it's negative, it'll actually flip it over the y equals x. Okay? Any major questions? Yes, no, maybe? So if I ask you to compare your function to the parent function, is everybody okay with what I'm asking for or no? Okay, so you're going to compare the slopes and then compare the y-intercepts. So here, what do you recognize about the slopes? They're what? They're the same, right? So did I change the graph at all by changing slope? Now, how did I change it? I changed the what? The y-intercept. So when I change the y-intercept, that's just a change up or down. So here, graph the following function and compare it to the parent function. My comparison would be slide the parent function up 3 units on the y. That's what I would say. Okay, because your y-intercept shifted from 0 to 3. So I'm taking my graph and I'm just sliding it up the y 3 units. Okay, if this were a -3, which way would I have slid it, up or down? Down 3 units. Is everybody okay with that? And then over here on the previous slide, we changed the slope. We went from a slope of 2 to a slope of what? Or sorry, what's the slope of the parent function? 1. So I went from a slope of 1 to a slope of 2. So what happened to the graph? The graph y equals 2x is more steep or steeper than the parent function. Something along those lines. I don't need super mathy talk. I just want to make sure that you understand what the connection is between a parent function and the graph you're graphing. Is everybody okay with that? So that's why it's more steep than like a slope of 1, which is just up 1 over 1. So slope-intercept form, everybody remember slope-intercept form? So what's your general slope-intercept form? What's your generic phrasing? Y equals mx plus b. Okay, and again, what's the m stand for? Slope, and what's the b stand for? Yep. Y-intercept. Okay, so when we graph, which one do we use first, m or b? We use the b. Once we find the initial point, which is another name for our y-intercept, then we use the slope to find a second point on our line. And again, how many points does it take to make a line? 2. Minimum of 2. Okay? So we only really need 2 points, but we prefer 3, just to make sure that we're not screwing up. Okay? So, over here, what's our slope? And what's my y-intercept? Okay, so when I graph, where do I start? M or B? B. So what's my B value? 3. And okay, is that an x-intercept or a y-intercept? A y. So how do I find where B equals 3 is? From where? So from 0, 0, I go what? Up 3 and I place a point. This is my initial point. Yeah. So the y-intercept, what that stands for is that's where your graph is crossing the y-axis. Okay, they're telling you, hey, we're going to cross the y-axis at 3. So that gives you 1 point automatically that's easy to find. Right? X-coordinate 0, y-coordinates 3. From my initial point, what do? I use the what? The slope, which is always thought of as a fraction, right? So from my y-intercept, what does my slope say to do? Go up 2, 1, 2, over 1, which way, left or right? To the right. So this is another point on my line. Everybody okay? Okay, now do I really have enough room to go 2 more and 1 over? No. So what do we know about a negative divided by a negative? What does that get you? A positive. So is my slope positive here? Okay, so what would happen if I go down 2 and 1 to the left? Do I still get the same values? Yeah. So that's what I'm going to do. Go down 2, go 1 to the left, and get my third point. Everybody okay with how I'm building this? Yes? No? Maybe? So sometimes, you know, you guys tend to just extend the graph, which is fine, but then you're losing accuracy. So remember, if it's a positive slope, go in 2 negative directions, right? And that still gets you a positive. So we use the third line, or the third point, just to guarantee the accuracy of our first 2. And once we look like, yeah, okay, that's a straight line, then we go with it. Everybody okay with slope-intercept form, right? You remember all this stuff from the last 3 years? I hope. Everybody good? All right. So, okay, so what's standard form of a line? I've already talked about it. Does anybody remember what's our generic standard form of a line? So in standard form, AX plus BY equals C. When they give you a function in this format, we can graph in 3 ways. We can make a table like normal. We can solve for y and convert it into slope-intercept form. Or we can do what's called a quick graph and graph by the intercepts. So what that means is you calculate the x-intercept and the y-intercept, and those serve as your 2 points. So if we're looking for a y-intercept, right? So if I'm anywhere on the y-axis, what's my x value anywhere on the y-axis? 0. So all I do is I plug in a 0 for x, and that's going to get me my y-intercept. Everybody okay with that? Yes, no, maybe. So how do you find an x-intercept? X-intercepts happen when y is what? 0. So a 0 for y gets me an x-intercept. And all you really need are the 2 intercepts, right? You have the x-intercept and the y-intercept. Plot them, connect the dots, you're done. Everybody okay? So plug a 0 in for x. What's 3 times 0? So that gets me 2y equals 6. How would I get y by itself in that? And what's 6 divided by 2? Everybody okay with how I'm finding that? Or do you want me to write it out? Yeah. So we take our function, and you plug in the x value, right? So I know 0 equals x. So 3 times 0 is 0, so that leaves me with 2y equal to 6. And then how do you get y by itself? Divide by the 2, and y equals 3. So there's 1. And then over here, we're going to take the same function, except this time around, what's my y value? 0, right? Like that. So I'm trying to find the x-intercept now. So what's 2 times 0? So I get 3x equals 6, and how do you get x by itself? Divide by 3. So x equals 2. So now I have my x-intercept of 2. Yes, ma'am. You get to choose what I'm going to tell you. If y is isolated, slope-intercept form. When you're in standard form, this is the easiest way to graph. Okay, but if you wanted to, you could get y by itself here. So you would isolate y and get 6 minus 3x all over 2. And then get this to 3 minus 3x over 2. And now that y is by itself, you can use slope-intercept form. Okay? But it's a step beforehand, or you can just plug in zeros. It's your choice, as long as you're right. 2, 1, 2, 3. And I place my intercepts. I have an intercept on the x-axis of 2, right? X equals 2, y equals 0. What's my y-intercept? 3, 0. Grab your ruler. So you can do it either method. It really doesn't matter as long as you're comfortable with it and you're right. Right, so we're basically going to be dealing with just 2 line types in this section. We're going to be dealing with slope-intercept form, and we're going to be dealing with standard form. Everybody all right with that idea, yes, no? Up next, horizontal lines versus vertical lines. Again, we've already started talking about this. So, horizontal line, what's the slope of a horizontal line? 0. Everybody okay? Yes, no, maybe? Okay, what about for a vertical line? What's the slope of a vertical line? No. Undefined. Right, that's where you have a 0 in the denominator, correct? Okay, does anybody know what the equation to a horizontal line looks like? We have 3 line types. Vertical lines, horizontal lines, and then we have skew lines. Okay? Vertical and horizontal lines are when only one variable is present. Okay, so for a vertical, right, you said slope is undefined. Horizontal is when slope equals 0. Skew is m equals anything else. Okay, the easiest way to remember this is which way does a vertical line go? Up and down, right? Which axis is an up and down line going to cut? Is it going to cut the x-axis or the y-axis? X. So this is when x equals some number. Okay, so for the vertical and horizontal lines, they're present when there's only one variable. Everybody okay with that connection? Yes, no, maybe? So what about the horizontal lines? Which way do they go? They go side to side, right? So which axis are they going to always cut? The y. So this is y equals a number. Okay, skew lines are when both variables are there. So both variables. So that could be y equals mx plus b, or ax plus by equals c. Okay? So if you see 2 variables, your line cannot be vertical or horizontal. It has to be something else. Everybody okay with that? Yes, no? When one variable shows up, it's either a vertical line or a horizontal line, depending on which variable is present. If the only variable you see is an X, it's a vertical line. If the only variable you see is a Y, then it's a horizontal line. Everybody okay with that idea? Yes? No? Maybe? So if you look over here, right, let me clear that off super quick. Think. Right, so horizontal lines are Y equals. Vertical lines are an X equals. So can somebody give me an example of the equation to a horizontal line? Because what we're saying is there an X up here at all? No, so I'm saying whatever X is, what does Y always equal? 3. Okay, that's what I'm saying. So if X equals 5, what's Y? 3. If X equals negative 2, what's Y? If X equals 843, what's Y? Everybody okay with how this is working? We don't care about X at all. No matter what, Y is always 3. So that's what creates the horizontal line. So if you have a line that says Y equals 3, that means that forever you're going to get the exact same value of 3. And that's what creates the horizontal line. Hey, get over here. Is everybody okay with that connection? Yes, no, maybe, questions, comments, concerns? If the equation is Y equals 3, yes. But that's what creates the horizontal line. So there's like Y equals negative 2, right? It'll be a horizontal line that crosses the Y-axis at negative 2. Is everybody okay with what that connection is? So when we drop a variable, we're saying, I don't care what that variable is doing, we're always going to get this result. And that's what creates the vertical or the horizontal line. So can somebody give me an example of a vertical line, of the equation to a vertical line, sorry? X equals 1. Okay, so where is it going to pass through the x-axis at? At 1. So I go to 1 on my x-axis, and then regardless of what my y value is, what's my x value always going to be? 1. So that's what's creating the vertical line here. Okay? Is everybody all right with that connection, yes or no? So the easy way to tell if you're looking at a vertical horizontal line or if you're looking at a skew line is how many variables are there, right? If you see 2 letters, what does that have to be? Skew, which means slope, intercept, or standard form, right? If you see 1 variable, what is it? It's either vertical or horizontal, depending on which variable is there. Is everybody okay? C just is a generic letter. It means any number. So it could be x equals 2 halves. Not 2 halves, sorry. That's 1. 3 halves. So that means that you're at 1 1/2. It can be any real number. So basically any value along our number line, we can write an equation for. All right, so everybody good with horizontal and vertical lines, you think? Any questions on standard form? Any questions on slope-intercept form? So here's your homework. All right, we've got 10 minutes left. Let me get the stuff passed out that I need to get passed out. Please get this copy down.